Hello everyone, myself Sagar Ramesh Kutte, working as Assistant Professor, Department of Physics, JMD College, Sinnar, Nasik. Now, last lecture we will discuss laser mode, line broadening, full width at half maximum and gain bandwidth. Now, in this lecture we will discuss example. First example, the half width of the gain profile of laser material device is 0.003 nanometer, emitted wavelength of 6328 angstrom. Calculate the maximum length of cavity in order to single mode of the oscillation having refractive index is 1. Now in this numerical given, lambda is equal to 6328 angstrom. It convert 6328 into 10 raised to minus 10 meter. Delta lambda is equal to 0.003 nanometer. That is, nano means 10 raised to minus 9. It's convert 0.003 into 10 raised to minus 9 meter. Mu is equal to 1. We will calculate L. Formula. The half width of the gain profile of laser material device is delta lambda is equal to lambda square upon 2 mu L. Now in this numerical we will give value delta lambda, lambda and mu. We will calculating L. Now rearrange this equation in terms of L. L is equal to lambda square upon 2 mu delta lambda. Put this value. L is equal to 6328 into 10 raised to minus 10 square upon 2 into 1 into 0.003 into 10 raised to minus 9. Now calculating this equation, we will get value of L. L is equal to 0.06674 meter. Convert centimeter. L is equal to 6.674 centimeter. Hence maximum length of cavity is 6.674 centimeter. Now next example, the half width of the gain profile of helium neon laser material device is 0.002 nanometer, having length of cavity 10 centimeter. Calculate emitted wavelength of laser in order to single mode of oscillation having refractive index of material is 1. Now last lecture we will calculate the length, and in this lecture we will calculate the value of lambda. Given delta lambda is equal to 0.002 nanometer, that is 0.002 into 10 raised to minus 9 meter. Mu 1, length 10 centimeter, that is 0.1 meter. We will calculate lambda. Formula. The half width of the gain profile of laser material device is delta lambda is equal to lambda square upon 2 mu L. We will give the value of delta lambda, L and mu. To calculate lambda, rearrange this equation in terms of lambda, that is lambda square is equal to 2 mu delta lambda into L. Put this value in equation. Lambda square is equal to 2 into 1 into 0.02 into 10 raised to minus 9 into 0.1. We will get the value of lambda square is equal to 0.4 into 10 raised to minus 12. Now this will be the value of lambda square. Now calculating the value of lambda, that is lambda is equal to under root of 0.04 into 10 raised to minus 12. That is the value of lambda is equal to 6324 into 10 raised to minus 10 meter, that is 6324 angstrom. Hence the emitted wavelength of the laser is 6324 angstrom. Now this will be the example of module 4. Thank you so much.